Hey everybody, it's Lost in Thought, and I just wanted to show you guys a pattern I found with 3's, 6's, and 9's, and I can't find it anywhere else, so maybe this will get big because, I don't know, it's cool. So let's say that you wanted to multiply 33 by some other number, but let's say you don't have a calculator on hand. Well, for some ones like 3 times 3, or 33 times 3, and maybe you're smart enough to know what 33 times 33 is, and then obviously this one's easy too. You know, it's just 9, 99, 1089, 999. But what happens when you have 9 3's times 4 3's? Or what happens when you have 6 6's times 5 6's? Or what happens when you have 4 9's times 2 9's? Well, I have the answer. For the 9's, what we're going to do to find out what the pattern is we're going to have two variables, A and B. Now A is going to be the number of 9's in the first term, and B is going to be the number of 9's in the second term. And we're just going to say that A is always greater than or equal to B. So if the second term is greater than the first one, we're just going to switch them and pretend like the second term is the first and the first is the second. Otherwise, we just leave them. So I'm just going to set up a table of values here, just to demonstrate what I mean by A and B and stuff, because when I showed this to some of my friends, they were like, what are you talking about? So this is what I'm talking about. So if you have 99 times 9, A is going to be 2 and B is going to be 1. If you have 9,999 times 99, A is going to be 4 and B is going to be 2. If you have 9 times 9, they're both going to be 1. And if you have 999 times 9,999, A is going to be 4 and B is going to be 3. Don't get fooled by the whole order thing. We just swap them. That's all there is to it. So, given these values of A and B, we're going to find out what those multiply out to. So 99 times 9 is 891. And then the next one is 989901. And then obviously 81. And then 9989001. So you'll notice that there's a lot of 81s. There's just, obviously 9 times 9 is 81, but there's always like an 8 and a 1 somewhere in the other ones too. And then there are a couple of 9s and some 0s just for good measure. Well, how does that all work out to a pattern, you ask? I have the answer. So there are some 9s left of the 8, the 8, some 9s right of the 8, some 0s, and a 1. So for the 9s left of 8, we're just going to call that X. For the 9s right of 8, we're just going to call that Y. For the 0s, we're going to call those Z. And obviously, X is the number of 9s left of 8. So X is going to be B minus 1. That's the pattern I found. Y is going to be A minus B, and Z is also going to be B minus 1. So X and Z are just the same. You should always see the same number of 9s left of the 8 as there are 0s. One thing that might be frustrating to you is that I can't prove it. Sorry. Anyway, for 6's, using the same table of values, you get 396 as 66 times 6, and then 6,666 times 66 is 439956, 36, and 4439556. So you'll notice there's a lot of 36's, and that's because 3 and 6 are the certain 8 and 1. 3 is now the new 8, and 6 is the new 1. Also, instead of 9's left of 3 or 8, we have 4's now, but we still have 9's right of the 3, and then we also have the 5's. And we're also just going to call them X, Y, and Z again, just because. And guess what? They are the same exact thing. So it's the same way to get it, it's just different numbers. It's 4's, 3's, 9's, 5's, and 6's. Well, I guess it's just 1 3 and 1 6, but you get the point. So for 3's, it's going to be slightly more confusing. So we have 99, 109989, 9, and 1109889. Now you'll notice, instead of, 81 or 36, we just have 9. I figured out what happens is it's a 09. That is our special 2-digit number. So obviously the 0 is our new 3 or new 8. So it's number of 1's, and then 0, the number of 9's, and then the number of 8's that you have. And once again, we're going to call those X, Y, and Z. And would you believe it, they are once again the same exact things. So that concludes this. I hope you enjoyed it. If you liked it, then please like and favorite the video on YouTube. And also, please subscribe if you want to see more of this. I might have more, and I'm going to talk about that in the next slide. But thanks. So in the future, I'm planning to maybe do triangle numbers and, sums of square numbers and sums of cubic numbers maybe. I don't know. And I might do Cardano's method, and I might do other things. I don't know. If you guys have any requests as to what I should do, I'll try to do it, if I can, if I get around to it. So anyway, thanks for watching.